This is our from scratch implementation of decision tree in Python. And my apologies, my video from yesterday got deleted. So I have the code ready with me and I'm going to go through it so that you have it on the weekend. For those of you who are new and are just learning about the channel through this video, we are doing a 12-week marathon where each week we're dedicating to one algorithm. So this week is on decision trees. And we've done a bunch of videos throughout the week on understanding math and intuition behind decision tree. And this is our final video of this series to understand the code from scratch. And so far, we've been looking at the data set of a basket of fruits. So essentially, there's a basket of fruits with apples, oranges, and banana. So step one, I'm going to stick as closely as I can with our pseudocode so that it's easier to follow since we've already looked at it and understood the foundational elements. So step one is just collecting and organizing the data, and that's what we're doing here. This is our data set where each row is fruit with its features. Label is just type of fruit, apple, orange, or banana. And then we have our color, red, orange, yellow, green. And then we also have round, which is yes or no, whether the fruit is round, and then has peel, yes or no. So our features are color, round, and has peel. So this is just to keep tracks of all the columns. And then what we're doing here in our process data is just basically converting the data set into a structured format. So each row becomes a tuple and data set equals to process data. So this calls this function to process our data. Okay, that's all that's happening here. And our data set looks like this. Now, step two is just calculating entropy. Those who are not familiar with the math behind entropy, we have a video on it. But recapping, your entropy, your H is just negative summation, probability of I log 2 probability of I. So the function calculates entropy, which is how mixed the data is, and then it counts how many times each label appears using the counter. And it computes probabilities pi for each class and then applies the entropy formula and then returns the entropy value. So that's all that it's doing here in our entropy function. And then here, what we're doing is in step three, step three, what we're doing is it splits the data set into two groups. So left group is where samples where feature index equals to value, and then a right group is the one where it's not equals to value, so it essentially returns two groups, our left split and right split. So that's what is happening in step three. Again, in the pseudocode video, we've walked through the intuition behind it. So if you're feeling a bit lost, feel free to refer back to that video. And then our step four calculates weighted entropy. What's happening here is it's just computing weighted entropy after a split, and our formula for weighted entropy is H split equals to n left by n H left plus n right by n H right. So it's essentially just applying the formula and returning it, and this helps ensure that larger groups contribute more. And then if we move to the next part, we're trying to find the best split here. So what's happening? We're finding the best feature and the value to split on. It loops through all features and tests every unique value of that feature. And then it computes information gain, which is how much the entropy decreases, and then returns the best feature and value. And we know that our formula for entropy gain is just H before split minus H after split, right? So we have that, and after split is of course our weighted entropy. So we have that here, and then in step 6, what we're doing essentially is we're recursively building the tree. If all labels are the same, and then we're simply returning the label, and then It finds the best feature to split on. If there's no improvement, it returns the most common label, otherwise splits the data into left and right branches, and then recursively builds the subtrees. And we've looked at it more on the pseudocode video, so please feel free to go and watch that video. Sorry, it feels like advertisement, but we really did cover a lot in that video because we were trying to build foundation for this video. And then finally, all we're doing here is following the tree to classify and sample. And then it compares the feature value with the question, moves left to right based on the answer, and then it returns the predicted value. So I've given it like green, yes, for our round, and has peel as no. And it has correctly classified it as apple. If I do red, then also does apple. If I do yellow, and then has peel, yes, round, no. Then banana, and then I'm going to do for orange, which is round and has peel. And then let's just try a janky number for funsies. Sorry, not number. I'm going to do some oranges are, what other colors are oranges? Not oranges, let's do apple. Apple colors. Purple, purple red. Let's do purple. Purple. Just because that's something not in our training data set. It is round, but it has no peel. So I'm thinking about this purple red apple, and I'm trying to see if it classifies it correctly. Okay, it does. I mean, of course, this one's very simple, but you get the idea of how to implement decision tree from scratch with this. Good luck.